Hi, everyone, and welcome to Kotlin London. This is Publisco, and I'll be your host today. Behind the scenes, we also have Guillermo, Enzo, and Amar, and make sure that the show runs smoothly. Also, it wouldn't be such a great meetup if it wasn't for you. So thanks all of you for tuning in. We keep growing month to month, and love to see how many new faces we have on the meetup. If you haven't already, please join our meetup page, hit the subscribe button on YouTube, and don't forget to do the bell thing so you get notified every time we do a new video. You can also follow us on Twitter at Kotlin London. And if you know or might, you yourself or you might know someone that might be interested in giving a talk, let us know. We're always looking for new and interesting talks. So let's get to sponsors. Thanks to 47 Degrees for sponsoring Kotlin London. Please check out the training courses and in Kotlin and functional programming. You can find a link on the description below. Also, if you want to get into streaming, we think that StreamYard is a really great tool to use. Use it all the time. And to help you start it, we also have a referral link down in the description. If you sign up for one of the memberships, we get discount in hours, which help us reduce the cost. So today we have two great talks, one from Raúl Hernández López and another one from Uberto Barbini. Big thanks for them to joining us and sharing their knowledge. And as usual, we'll hold a short Q&A after each talk. You can post your questions straight into the YouTube chat with hashtag ask. We will show them at the end of each talk and talk with the speaker about your questions. Also, everyone that participates will get drawn for a couple of IntelliJ licenses. So make sure that you join the conversation so you can get potentially a free license. Also, during the talk, please make sure that you encourage with emojis and short feedback in the chat. The speaker can see the chat, and it really helps them to get to see that you're engaged and to see your nice words. So let's get started. Let's welcome our first speaker, Raul. You have the floor.
To start for today, so let me present you my presentation today. We're gonna see getting ready for declarative UIs, basically using Unidirectional Data Flow and Kotlin Coroutines. But first of all, let me introduce myself. I am Raúl Hernández López. I work as a software engineer at Twitter for a few years now, 3 actually. And yeah, if you want to follow me, you have here my handle on Twitter, also my GitHub account user ID, where you can also see the code snippets of this presentation later on, basically from the Gist account more than the GitHub one. But that's me. So let's see basically the agenda for today, which is the important bit. First of all, I will start analyzing a use case where everything hopefully will make sense to you. Then later on, I will continue with analyzing the existing architecture, because probably we don't want to change the architecture that we have if we want to progress and do some iterations of this. Then from this architecture, I will start adopting unidirectional data flow, and I will make sure that you see the different implementation details that I follow for me this approach. Later on, the different lessons learned and why Compose can be a choice that matters for us on Android. Next steps. So let's see, first of all, the use case. The use case is basically the search mechanism app where I have like different things that are appearing, like the loading spinner and this one you see over here, these empty results when there is something failing and I am looking for something and this search query is failing. And then if I have any results, then a grid appears and then I can see by clicking in one of those cells of the grid, the detail view. And also the error message test. So I'm gonna focus for this presentation across the main screen that is a search functionality. Now let's analyze the existing architecture that I have here. And also, I will start adopting this into this existing architecture, as I already mentioned. So what I meant to make sure is that you understand that your architecture can be good enough to start using unidirectional data flow. So first of all, what I had is a data layer that is composed by a repository that is managing different data sources as the network and the database data source, giving back some results with the spam function, returning some results back to the next layer. So the data layer actually is communicating with the business layer, and the use case, the main entity of the business layer, requests this information to the repo. The data is coming with those results, and any transformation, any business logic, any calculations we need to do, gonna be happening here into the use case. Then what I had at the time being is callbacks coming from the use case to the other entities and passing the results into these callbacks. So the model view presenter, that is a presentation layer, is combined with the clean architecture starting from the use case. So basically, in the old times, when we used to communicate from the use case, the views and everything like that, we used to pass callbacks from the use case to the presenter and embedding those results into the callbacks. So basically, the presenter is the one connecting and executing the use case and making sure that the business logic starts in the old times with FVP and clean architecture. So then the presenter is passing the results back by means of the callback, and the view is going to reflect those things that are receiving from the presenter. Also, the user intention is typing a new query every time. So starting the typing of the query, and then everything is happening, and this mechanism is triggering. As you can see, both the view and the previous entity, the presenter, are built in Java. So this is a hybrid application with Java and Kotlin. So you can see that the presenter communicated the results to the view, and also the view is the one that, by the typing of the user, is passing those queries of interest to another entity that I created, that is a view delegate. I am extracting functionality from the view, from the logic of the view, and I am starting this query from this mechanism. So starting the search of the query, reacting to the different queries, and then the presenter will do this interaction for us. Now let's analyze the coroutines that I use over here. For instance, into the data sources, I use plain and simple suspend functions because I only need one-shot operations, basically. So I'm returning the results back by means of suspend functions, nothing else. In the repository, I use Kotlin flows because I am emitting more than one value depending on the catch policy that I have here. So you can do something like that, or maybe you have something similar. So this probably looks familiar. And those emissions are being received from the use case. So basically the use case is going to be the one transforming the things into whatever we need for the presentation layer and going to collect those flows. So how to get ready for declarative UIs is the main question that we're going to answer today. So first of all, what we need to do here is to make sure to understand if we need the callbacks or we don't need the callbacks. Do we need the callbacks or not? Because if the callbacks are ideal, maybe we don't need to do any change. But let's see. What can we find in order to see disadvantages from the callbacks? First of all, we have a guest today is Ryu from Street Fighter. He's doing a Yuken, and we can see that he created a massive indentation with many callbacks. Every callback is into another callback, and so on and so forth. So basically creating a callback hell. So we have something that makes our reliability not very good. So basically, probably this is not great. If we think about it a little bit, you can think like the problem here is the fact that at some point, if you have any failures in one of the particular callbacks, maybe you don't know what's the problem, where is the problem, and when happened. So this is going to be very tough to debug. So that's the main trouble here. But also we have other problems because the callbacks break an interesting principle from functional programming called reference and transparency. And this principle basically tells that the ability of making larger functions out of smaller ones through composition and produce always the same output for a given input. So that means that every time that you are passing a particular input, you will expect always the same output. And this means that it will be deterministic. So let's imagine a very small function like I pass an integer value, a 3, and I want to add 3 more to that. So it will always be 6 as an output. So something like that going to be the one that's going to demonstrate to us that we can test it and we can make sure that this code is reliable. So basically relying in referential transparency principle. So if we think in the consequences of having the reference transparency broken with the callbacks, what we have is that with the callbacks, we cannot really give a particular output because we don't have our return value with the callbacks. Either we don't have anything interesting here because the results are actually declared as input parameters for the next callback. So this is very, very difficult to test, actually. You think about it, because you cannot really have deterministic tests. You can have maybe white box testing, but you wouldn't have really a black box testing kind of, which gonna basically tell you that the thing that you are testing is valuable for that. So results can mutate with callbacks. You can mainly have something there, but you have many indentations for callbacks. At some point, you don't really know where this mutated. So that's the main problem here. So by that, we mean that we have lack of determinism, because if things are mutating, but we don't have a control of them from one side to one another, then this is a real problem for us. So are there any better alternatives to callback, really? So if we think about the things that Kotlin provides us, Stateflow can be a really good candidate to that, because Stateflow always returns the latest value when this value is different. If it didn't change, it will provide the same value that it was previously. And also, Stateflow provides immutable or read-only collections by default, because the contract of the Stateflow is basically an interface. So it cannot really change. You will instantiate the Stateflow with a mutable Stateflow, but you will expose only the Stateflow. So by the time you collect it, this shouldn't change along the way. So that means that Stateflow is deterministic by default. So we have this problem solved of determinism that we broke with the callbacks. So in order to change one thing to one another, basically we're going to remove those things from the use case to the presenter to the views by replacing those things with state flows that are going to be collected only into the view. But the view, you see, is written in Java. So actually we cannot collect this into a Java entity. All things that are being collected and need a coroutine context, they need basically a Kotlin file. And for that, I created this helper that is called for me Stateflow handler. You can call it whatever you prefer. And you will collect this Stateflow in order to be used whenever you need it. So let's adopt Unidirectional Data Flow now. But let's think about it a little bit more and what really means Unidirectional Data Flow. So this is as simple as one-way data flow. That means that we have one only way, one only, to get from one place to one another. So if we are starting from here, we should arrive here. And there is no other way to arrive here but from here. So this is the way that we're going to work thinking in unidirectional data flow. If we follow this principle, then we can actually rely in something that is immutable, because there is a starting state, something in between, and then an end state. So that's the main principle I want to focus today. So something like that. We have a UI. We intend an action. This action transforms those results from the action into a state. This state is rendered into the UI, and then the cycle starts again. The UI intends an action. This is transformed into a state, and the state is going to be a new UI. So basically, what we think here is a pattern matching of one state, one UI. It's always this relationship. One new state, one new UI. So it's basically atomic. One state is going to be always one UI. You should assemble, you should render this UI by means of one state only. Thinking about it, so we start from the imperative UI. Then we intend the action. I use my BYOB delegate. You can have something else here, of course. This is just optional. I trigger the action from the presenter. I execute the action, which is going to the use case. I assume that the use case receives the proper data from the data layer. Then this is dispatching the state. Stateflow handler communicates the state to the imperative UI that I already had. And we render this thing with this approach. So we basically implemented here unidirectional data flow without changing to declarative UIs just yet. But this means that if we have this kind of approach, we can actually make sure that imperative and declarative UIs can coexist together at the time being, which is the only way for us to adopt something new like declarative UIs, in my opinion. So by having this, we can actually replace the imperative UIs with declarative UIs. And when it's ready, we can just remove this imperative UI, having the other one onto this place, and we can actually use Jetpack Compose on Android. Some advantages of this kind of approach that I just mentioned to you: flexibility, because we can very easily use imperative and declarative UIs when we need them. And we have basically the means to do that. So if we need to use one or one another depending on our needs, we don't have this flexibility ready for us. Then the layers composition, by creating the smaller things into bigger ones, means that we can replace one thing with one another, and we can make sure that the things are working together. We can change also the architecture easier than if we have very big entities with many lines. Let's see some implementation details of this approach that I made for you. So data sources are composed by the network and the database. Right, so we are sending this by means of suspend functions to the repository. Then the data source implementation is composed by a few things: a Twitter API, that's a retrofit client sending the results back from the network, then something to retrieve things from the network and saying if we have any connection or not, and then basically interpreting those different requests and responses for us. Then the functionality is going to be just a search function with the token that we pass, because it's an authenticating token, and a query that going to be the one that is added by the user. And I am using here the either operator from the error library that basically in the left provides any exception or throwable that we have when there is a problem, or in the right side, we are going to provide the successful results that are coming from the network. This can be also used with a calling result. It's exactly equivalent, but it's just an example. Then passing this as a suspend function. So I have basically the table with the tweets, and I'm going to pass by means of the list tweet for me to use it in the next layer. So the repository now going to use those suspend functions that are coming from the data sources and going to emit different values for the flow. For instance, the flow is right here. So I'm going to emit as many values as I want to, and then I'm going to get those back to the result as I think are the best usage for the use case. So the repository going to use this network data source that you already know, and the different tables for the tweets, the token, the query, combination of the query and the tweet, and the different mappers to have this transform into the right entity. And something called task ready that is just a wrapper with the dispatchers inside that. So my functionality now becomes this one over here, and I'm going to return a list of tweets that can be an open string. That's why I use a flow. So let's see a few use cases by using a flow that can be interesting for you as well. And let's see. So here, what I tried when I was experimenting some time ago is basically a suspend function trying to retrieve something from the inside by using a flow. But actually, a suspend function is a one-shot operation, can only return one list of tweets, but not more than one emission. So that means that actually this is not possible. If you want to use suspend functions, it should be with another suspend function inside, and the wrapper of this suspend function should be a coroutine context. Something like this can be possible, of course, so you can retrieve the things and the suspend function with the list of tweets being returned with the get search tweets with a list of tweets. So basically something like that will be available inside this suspend function. And now, if we have different cases with the flow, what we have is that we can use the flow builder. The flow builder can also use emit all operator. This emit all operator can return all the things that are coming from the flow, and you have an open stream, and you are refreshing with a poll every, let's say, 30 seconds. Yeah, maybe you refresh the UI with this. This is perfectly valuable and can be used. Also, if you think about this, the flow on operator, make sure that everything upstream, everything into this block, gonna be using the IO dispatcher. Also, this is valid. You can use a flow builder and emitting only once with a suspend function into this functionality. But if you have this, probably you only need a suspend function, so maybe you don't need to waste resources by using a flow here. Cool. Also, we can emit different values. So we can emit first the values that we have in the database before we refresh from the network. We can send those back to have an offline experience, and then emitting new values again. And this actually going to be, again, into the IO dispatcher because it's an input-output operation. So this is a perfectly valid case, and the one I use for the sample app. Now, let's see the use case overview and what we have there. So the use case, if you remember, is again transforming the things and just returning the results back, requesting things to the repo, and then collecting the flow, right? And then the callbacks are here. So those are the things that we need to replace as well. So first of all, we want to implement the case with the callback, or I'm going to show you what I implemented, better said. So into the use case, I have the tweet repository and the coroutine scope that I'm going to use. for the rotating scope. Into this scope, I have a UI dispatcher and a supervisor job. Just very quickly, I'm gonna refresh you if you don't know already what this means for me. Basically, I use a scope, that is the one I want to use, and a supervisor job. The thing is, by using supervisor job, I avoid other schedulers cancellation issues. That means if the job 1 gets canceled because there is an exception thrown, basically I don't want to cancel maybe job 2 and 3. So that's gonna be made by the supervisor job. If I will have job instead of supervisor job, if job 1 cancels, then 2 and 3 gonna be canceled at the same time. This is for me because I made something custom, but if you have lifecycle architecture components and something like that, maybe you don't need to do something like this. The use case implementation gonna be as simple as this interface. So I'm gonna pass a parameter that is basically my callback. What I had there, the execute method gonna pass the query, and the cancellation if I want to cancel the coroutine scope. So I start the callback, I show the loader. Then after that, I start launching the scope, and inside that, the repository by searching the tweets with the query. So I am mapping the things that come from this query. I do any calculations that I need, and I will return this later on. So basically, the following again is upstream. That means that any operation for the map gonna be now into the computation dispatcher or the default dispatcher in Kotlin. Now the catch gonna get any problems, and I will send those back to the collector. And also, sorry, to the callback. And then when we collect, it's gonna be for every iteration of the stream. So I'm gonna pass this to the callback as well by the unsuccess method. This is equivalent as well. I prefer this because for me it's shorter, and basically launch in does the same that scope.launch. The only difference here is like the catch also could catch any problems coming from the ONH if there is any. If we cancel this scope, I will do this into this method, and that's all. I will nullify the callback to avoid memory leaks, and that should be all for me into this particular one. I will cancel by means of this and using Strato concurrency any problems that could happen with the scope because there are no memory leaks anymore. So synchronous communication with the UI. That means that I want to replace all callbacks with state flow. And by that, I mean that I'm gonna remove that, create a new use case. That's gonna be use case flow. And it's going to be as simple as removing those callbacks from there, creating a new method called get state flow that's going to expose a state flow with this parameter that we'll see in a moment. And then the good thing, state flow can be passed across different Java and Kotlin files. So that means that I'm going to use here my tweets UI state, that is my modeling for the UI, for the states. And I'm going to expose this particular one with the state flow, that is the interface that is read-only, as I mentioned earlier. I'm gonna generate this state flow by using mutable state flow and passing this tweets UI state, and I'm gonna add initially an idle UI state, because what I want here is always having a first state, because always state flow gonna return the latest value. That means at least the first one. So state flow always gonna use distinct until change by default. If you try to use distinct until change, it won't affect actually the state flow because it's already there. It cannot really be applied because it's there. Now, if we try to model our things, you remember I mentioned previously that I have a list of results. So that's basically this. I am passing the tweets. This is also super important. We should make sure that we use val or value, because this will make sure that we have read-only or immutable values. And that means that Compose will be able to understand that in every recomposition, only if these tweets have changed is the case when you're gonna really need to do recomposition. So that's good for Compose to understand. If you use var here instead, Compose will not really know if there is a problem. Also will happen with state flow because it wouldn't emit something with a var. So then the error UI state, when I use a message inside, so again the same, we use the val. Empty UI state, the query, like there are no results for this query. Then the loading UI state, just I want to show something. I don't want to show any new message that is something different than the one I have in streaks.xml file. And the idle UI state, if I want to show something at the very beginning before any mechanism of the search has started. So first of all, I start removing the callbacks. I use this onStar operator from the flow that is super nice and gonna make this more readable. So I basically use the dot value or set value actually for passing the first state, that is the loading. I want to show something before I go to the collection of this data coming from the repo. Then for every iteration of the stream, I'm gonna check if there are values for passing an empty UI state, or I'm gonna pass the list of tweets and I'm gonna set this state flow for this value as well with the tweets inside. If there is any problem, I will cast that and I will pass this to the view to basically tell to the user whatever I prefer to tell. And the launching gonna use the scope too. Then gonna collect the state into the state flow handler. So let's see what we need to do there. So search tweets presenter, which is in Java, just includes the use case and the cancellation of the use case if there is anything that needs to be nullified or any scope that needs to be also canceled. So when we are searching for tweets, we pass the query coming from the view and we execute this query. We don't need any of those things that we needed in the clean architecture, passing the callbacks from the use case to the presenter. So we can get rid of this right now. And we can expose the state flow from this Java file to the next stakeholder that's gonna need it. And that's basically it from here, from the presenter. So going to the delegate, I have this presented inside, and I will expose again the state flow to the next stakeholder. So this chain is completed. And now into the fragment, but it could be an activity, it could be a custom view, and it could be whatever you prefer that you need. So basically, I injected here my view delegate and the state handler, and I'm gonna make sure that the state flow is over there into the state handler, and I will pass the reference, strong reference from the fragment there that I will nullify later, and the process state flow collection. So what I'm gonna do is invoking that method into the onCreate view. That's when I'm creating the views. And then this is the method from the handler that's gonna basically assign the state flow and the reference to the fragment to this bar that I will later on nullify when I need it. And then when I am collecting this for every stream of the state flow, I'm gonna handle those UI states. So I'm gonna pass this when there is a change. And I will do that, of course, into a scope. That's why we need a Kotlin file. So now let's see how we can render into imperative stateful UIs. Stateful because imperative UIs always need a change into their own state that is embedded into those imperative UIs. So passing those states, I will render those over there. So how we can do that? So you remember this method that I mentioned, handle the states is passing the UI state. We're going to start showing the results. That's an extension function as well for the fragment, as well as the other one, the handle state, by passing the tweets. And this method is simply doing something like this, passing the tweets and starting to hide the loader. So basically, we are handling the state here. I'm going to make invisible this loading. I'm going to actually make invisible the error. I'm going to make visible the list of things. So the recycler bit that was gone, going to be visible now. And you can see the different entities from the recycler view. I'm gonna update the tweets for this particular one. So I am wrapping, as you can see, into the state flow this list UI state with a collection of tweets. Every single tweet gonna become one view holder, and that's what the adapter is doing, basically updating any one of those items. Cool. For the rest, you can imagine it's something very similar, so I won't talk about them, but you can imagine loading means that the loader is showing, the rest are hidden, and the same with the other states. idle.UI state for my imperative UI does really nothing, so I didn't implement anything here. Declarative stateless UI migration, because declarative UIs don't care about their own state. They care about the state that needs to be rendered according to certain rules. So that means we are dispatching the state flow handler is going to the rendering of this declarative UI. And then the fragment is using the search composable UI with the view delegate and the state handler. Cool. So how can we do that? So basically the XML layout is great because we can use compose view right there into our very big XMLs in order to start integrating compose. So the interoperability in compose is great, really. And actually, by doing this, just finding the view by ID, we can get the compose view and we can start playing with it. So I'm gonna pass this compose view to my entity called search composable UI. And as you can see, something as simple as that, I have this into my compose view, and then the state handler is initializing the state flow, passing this entity with the compose view into that. And the state handler gonna have those entities initialized here that can be, as I mentioned earlier, notified later on. And I'm gonna start processing this state flow collection when it's coming from the other layers. So basically, by processing this state collection, I'm gonna make sure to start composing the views by means of this UI state. So this is again the things being assigned into the search composable UI entity. And now the important bits and pieces of compose. Compose relies, first of all, in set content to start itself. So that means that the content should use always a material theme. Material theme is the one by default by the system, but probably you have something custom from your side. So you're gonna create something with your own colors and so on. So this is something very similar to coroutines because a suspend function needs to be into another suspend function, and this upper suspend function needs to be into a coroutine context. So likewise, compose needs a theme that is going to be composed by different composables. So that's why we're going to use states UI with a UI state, and this using a composable right there. That's the first one of our composables. So the composable is going to pass the UI state. We're going to start building upon here. So let's see now, declarative stateless UI handling alternatives, because maybe there are better ways to do those kind of things, writing less code. So I remove this state flow handler. I use UI state handler. So I'm gonna handle those UI states into my declarative UI that I am rendering. And I am again just changing one entity with one another by using the UI state handler right there. So I remove this entity from here, I injected the new one, and I'm gonna do something very similar. I'm gonna pass the compose view, I'm gonna pass the state flow, but I don't pass the UI state, and we'll see why in a second. I'm gonna do exactly the same right here, but into my search UI state handler, I'm gonna make sure that it is ready for collecting the state flow. But how is that even possible by passing the state flow right here? So as simple as that, by using into this composable, they collect at the state for the state flow to be collected into the composable. And this generates a state that is ready to be used into compose. This state gonna pass the tweets UI state that is wrapped into this state by means of the get value or value in this case. And now let's see how we can render those things, talking more about the UI. So first of all, we have the UI state that we already passed from the previous method, and we're gonna start rendering the list of things with a grid in this case. So I'm gonna pass those tweets with the tweets coming from the UI state, and the tweets grid coming with those tweets. Gonna start a lazy vertical grid that's gonna have a fixed number of columns. It could be also with adaptative, which is another method with this experimental lazy vertical grid, which is going to be depending of your size of your screen. And we'll pass different tweets with the size. And by means of this index, in this case, I get the tweet, the particular tweet that I will use for both the click option and also for rendering. So for the click, that's the method you saw earlier. That's the lambda. I'm going to pass this lambda. That's a higher order function that I use there. By returning this lambda, navigating to an activity with those entities that I need for my click happening from the lazy vertical grid to the tweet detail. Right. So I'm going to pass that lambda here, this function there, and I'm going to use this into the clickable. So I'm going to assign this to the onClick functionality. And I am using a box because I like the box, and I use that with the different options and the modifiers and so on and so forth. Then I'm going to start composing by view from top to bottom. So for that, I chose column because I'm going to have an element at the top that is an image and a space in between and a text. So that means that column will work likewise a linear layout. It's exactly the same. I'm gonna use first the image, and I'm gonna use also the remember call painter, because this gonna enable me to remember the image URL every time that there is a recomposition. So you don't need to actually again load the image if this image from this cell didn't change after recomposition, because maybe there is something else that comes from the tweet that has changed, but the image URL didn't. So gonna remember this for the next iteration of the recomposition, which is great. Also super important, please, content description is now compulsory. That means that you need to add for accessibility options your content description. But please don't add a quote, which means nothing. To have this as a workaround, please try to add some content description, because there are many users and we need to develop for all of them. Also, the space that we have in between the image and the center text. So the spacer with this particular height, and then the certain text. The center text only renders this name over there. So we have the different components in our column into this box. The particular UI states gonna render this. So the list, we have it already. I reuse actually the center text, and I will use the strings from the strings XML, and I compose also my different queries and the error and everything coming from this UI state. Great, this component is as easy as this one, just creating a text with a particular pattern and style with the body and overflow to the bottom. You have this very big into the width. And then finally a top text. The top text is same than the previous one, but just aligned to the top. So to finish the implementation details that I wanted to tell you today, basically we want to remove the different things, canceling the scopes, removing the different entities to avoid memory leaks here and there. And the same with the state handler, removing the composed view, which is going to be an actual memory leak if you don't remove a view from one of the entities being injected. And the same with the other things. So we're going to make sure that when we are destroying the view, everything is canceled or destroyed, or we don't have memory leaks basically. And with that, Declarative ready with unidirectional data flow within this approach. So this is the example that I want to show you today. So this is me trying to get to a particular query. The top text, you have the start typing there. This is working. The loading was super fast. I didn't make anything very fancy, so that's why you didn't see that probably. If I will fail, I will show the int result text, but you see the list of results with the grid. As simple as that. Some lessons learned, and for me the most interesting bit of this presentation, so bear with me. Interoperability, because Compose is really, really amazing, does a very good job with interoperability in general. And that means that we are ready in both sides of this coin. Basically, in one side I explained the Compose view, I won't tell this again, but on the other side, you could also use Android view, because imagine that you have an endless kind of view that you cannot really remove today, and you want to use it into another thing. So actually you could start a Compose view in a new screen, and then using this super fancy custom view with maybe EXO player, and you want to include this into another screen. So you can include that very easily with Android view. Recomposition runs multiple times. That means that if this happens, you have to be ready for those. And you can fall into pitfalls like memory leaks, block the UI thread. So you have to be very careful and write the code that you only need, because the declarative paradigm gonna make sure that you write it the right way, or you're gonna have some troubles. Remember, we'll save the previous state in the view, as I mentioned earlier with the one used for the image. I was remembering this URL, so you don't need to load it again after recomposition and something else changed. And that's great. Also, composition local is a very interesting term to learn. And according to the documentation, it's the simplest way to pass data flow to the tree and its children. So that means that if you want to go to one of the branches of your tree and you want to insert a particular value there, you don't need to go from the very top composable and passing this into all your functions over and over and over again. So you can just rely on composition local, and then creating this for this particular one that you want to inject to. And this is basically something that probably you remember called dependency injection. So this is applied to composables. Composables should be side effects free. What do I mean by that? Side effects free because ideally into your UI, you wouldn't run a network operation or a database operation. But if you need to do that, then you need to use something called effects handler that Compose provides for you. If you do that, after every recomposition, if you need to run something in particular, it will be run at the right moment, and you can make sure that you don't do any mistakes in there. Unidirectional data flow likes states, but really likes them. So that means that you need to make sure that everything is state ready. Otherwise, you're going to run into different pitfalls like unpredictable states. If you don't render every single state that you need for all the cases, you don't have something deterministic because you are missing cases that maybe you need to rely on at some point. So be aware about that. Imperative against declarative programming, because it's always difficult to change a paradigm, right? We got used to be used in the imperative way when we need to change the visibility, modify the state, maybe make something disabled for a button, something like that. And with declarative UIs, we are more relying on what we need to do rather than how we do it. So basically, we want to say like, yeah, I want to render this, but you wouldn't say this is visible or not. You just render it or you don't render it. That means that in the slot table, into the tree, you will either, after every recomposition, render it or don't render it, but you wouldn't rely on a particular state. But why compose after all of this? Because maybe we love to have 3,000 files like the view, which is even more actually, or you love to have XMLs one over the other. Why compose if we are so happy with those things that we already built? Well, let me show you a few reasons that maybe could change your mind. Compose runs in parallel order and very frequently. That means that is aimed to be very, very performant. And maybe it's not as performant as it could be right now, but in the future, it aims to be that like that. Obviously, because the OS is what the views provide, because the views come from the OS, there are things that you will need to still go to the previous views, but Compose is a very nice thing to use nowadays. And now is almost there with the stable version in July we'll have. But Compose also is stateless. It also enables us to be more predictable. It means that we can create things that are immutable and gonna change depending on those things that have really changed across the different moments that we have for those states. So that means that we can actually make sure that our apps are more deterministic and we can really understand what is going on. Because if we rely into classic views, it's gonna be stateful. You're gonna change state into one of the views, but imagine you have an XML with a custom view, with a switch into this custom view, and this switch and the other switch change. They have their own state. You have to coordinate. You have to have an orchestrator for those particular states. Those can mutate. There is a problem with those mutations. You don't really know what is going on there. Can be unpredictable, and you cannot really test something end to end like that. Also, Compose, and it's Kotlin, so you better start migrating into Kotlin or start migrating little by little like I did there. Otherwise, you cannot really use Compose. Classic views run with Java and Kotlin, obviously going to be for a while, for sure, because are part of the OS. But now let's talk about the different things that can be also interesting. Performance improvements are something that are coming to Compose. We have actually things that are super performed into Compose, but there are probably things to improve that are going to happen at some point for sure. Testability, because if we did the right thing across the different things and coming to the view and everything is tested already because we have those states that can be really, really easily tested, when we go to Compose, we can actually test the view because the things that are coming by piece of the state are going to be the things that are going to be predictable. So that means that you can just rely on snapshot testing or espresso-like testing, and you can have the rest ready already. So you have a better testable app as well. Reusability of UI components, because you can create generic components very easily with Compose and with much less lines than with regular imperative views. experimentation of new ways of working, because you can use and you can be running based UIs on your backend. Backend can drive your UIs according to a particular state. You can define that, hey, for this particular screen, you have those states, you're gonna render those, and then your app can run those states depending of your backend choice. Next steps, I think adopting explicit state declarations today is a good decision, basically because we are in June. Next month gonna be stable compose, and better we are ready or we are going late to the party to use and enjoy compose. So better start today than tomorrow. If you need to understand a few details from this presentation that maybe you lost in translation, I have a set of articles I will share into my Twitter account, Raúl Hernández L. Later on, those slides gonna provide those links for you with different Medium articles. And in the end, something about state flow that in combination with the part 2, you can understand probably better. Also, special thanks to Nick Butcher for reviewing those slides back in January before I obviously modified this a little bit and updated it. Thank you today, and thank you for Kotlin London for inviting me today. Very happy to be here with you. And if you have any questions, I'm gonna be more than happy to answer them.
Yeah, I think we do. So, by the way, thank you for the talk. It was super interesting. So let's see what question we have first.
I think
we did.
Pablo. Now I hear you.
You hear me now? Great.
Yeah, perfect.
I was just saying that. Thanks for the talk. It was really, really, really interesting. I'm glad to see we're not the only ones using Compose. So, Nafio, I hope I'm pronouncing that correctly. If not, sorry, asks, what would be the major benefit of using Stateflow instead of live data, except for the initial state?
So the main benefit, I think, is like you can use your code built with Stateflow everywhere. So if at some point you're going to start migrating into Kotlin multi-platform, or you want to rely into something not Android specific because you want to isolate those dependencies out of your app, Stateflow going to be a relief for you. Otherwise, with live data, you can do two things using them because it's simpler and has few cases that are very specific to Android. But at some point, I am very sure that Google will deprecate it, and you will you will be not very happy of that decision. So maybe you will then decide by force to use something else.
Maybe the new loaders. So let's see what we have next. Again from Navio. So he asks, is that either something custom or exists in the framework, the standard library?
Yeah, I think also Pablo can answer to this question, but I'm gonna do that very quickly. He can stand if he likes. Yeah, either is from the Arbor library. This is the t-shirt of the Arbor library, by the way. And it's basically a functional programming library that was built by the community and also being maintained nowadays for 47 degrees. So basically, the either operator is interesting, but also calling result gives you the same. Obviously, using Arrow, you have many more possibilities. So you go to the functional programming wall is the best choice for sure. So it's really up to the people to choose.
We'll make sure to put a link of that on the description. So let's see what's next. So Alex asks, what is the correct way to use immutable access to mutable stateflow via separate get method or explicit immutable property, like with live data, like the example of live data with underscore property?
Okay, I'm gonna be very opinionated here as Google is as well. So if Google doesn't like my answer, sorry, not sorry. So I prefer to use methods like the getter or something else. That's my personal preference. And I prefer that because if you create a variable just to expose another variable, you are creating two variables. So you are basically creating more objects to memory to be saved. So that means that you are creating more things for the stack of the memory to have, like, you're just thinking in the memory registers. One object, another object. What is better, two objects or one object for the memory? If you have endless resources, maybe 2 objects is not a problem, because we have very good mobiles nowadays, so it's not really a problem. But why do you need 2 objects for? For exposing another object, you can just create a method which is exactly the same. I don't know.
There is a feature request somewhere in the Kotlin language issue tracker that they're going to hopefully in the future have a different return value from the internal value. But until then, yeah, for the function would be lighter. Okay, so next question. Is that the last one? Oh yeah, that was the last one. So I think we're going to do the raffle at the end so that we have a bit more questions for the question for the licenses. So thanks a lot for coming.
Thank you.
And hopefully we see you again.
Hopefully.
Oh, there you go.
Thank you, Nico.
Thanks.
Thank you, everybody.
So if I can get, yeah. So our second speaker will talk about a hot topic in the, this is the wrong copy. Sorry about that. Let me introduce our next speaker, which is Uberto. So if you want to come in. There you go.
Hi.
Welcome.
Okay, I'm Uberto. I work on Kotlin since a few years now in the backend. Let me share my screen actually. Yeah, just yeah, share the screen. So yeah. Yeah, can you see my screen? Yeah, there you can see the screen. Okay, I'm currently writing a book about functional programming in Kotlin, which I'm very happy. Hopefully should go in beta soonish. As soon as I found a bit of a time, it's really hard. But I hope to go in beta before end of this summer, basically. And yeah, a lot of things that yeah, the previous speaker was saying was absolutely thinking. I mean, spot on. I'm on Twitter. If you want to follow me, I'm Ramtop because Ramtop was something ZX Spectrum, and it was some kind of cool at the beginning. But anyway, today we will talk about Kondor. So what is Kondo JSON? So it's a library to serialize and deserialize JSON fast and safely without using reflection, annotation, or code generation. And I think that you are thinking, okay, but why bother? I mean, what's wrong with the reflection or annotations? And yeah, actually, there is nothing wrong with that if you okay. But for the project that we were working on, basically, we didn't want to have the basically to some. We like to refactor a lot our domain class, and we didn't want that our refactoring was basically impacting the JSON. And also, we didn't want our domain class to be full of annotation. And also, we didn't want to have to copy our domain class to, for example, a DTO object or stuff like that. So you think, I mean, we were a bit of a very fussy team, I have to say. But it was also a lot of fun. And we came out basically with a kind of a DSL to write the JSON. And there are actually some DSL like that. One is called Argo, for example, or stuff like that, where basically you define the JSON DSL. But after a while, we got kind of tired of DSL. And so I wanted to write something basically to get the idea that, okay, I wanted to map my domain object to to a kind of a JSON shape. And I wanted this map to be kind of a bidirectional. So from the map, I wanted to go back to the object or go back to the JSON in both ways, without having to write the DSL twice. And so far, so good. You say, OK, so we start basically creating our own library, which you think is a kind of, yeah, we are inventing the wheel. But sometimes we have to, because I think we kind of have some kind of niche requirement that actually wasn't covered by any other library. I'm quite happy with it. We are using in production also with another team. I changed the team, I changed company, and we're still happy to use it. So I hope someone else will also find useful. The current version is 1.5.3, but I want to show you some code. Basically, OK. So I hope everybody can see my screen. And this is, well, let me show you. So we have this Star Wars API, which is a REST API website to get Star Wars information. So something super professional. And what we want to do is writing a client with our favorite language to be able to do this stuff. So this is how the client will work. So there is an HTTP client when we set basically the basic URL where we are getting the stuff, and then we are using Jet. And this is, by the way, this is all HTTP4K, which is my favorite framework to do, or library, actually, should be more correct. My favorite library to do web-related stuff, both in client or server. But here, we just need the client part. So what do we do? Basically, we have this API. Then we connect here. We basically created the URL in a very simple way with the request get, and then we pass the response, or we print the response. So if let's clean stuff. Okay. So if I run the stuff and everything goes well, yes, I have this is the JSON back. And sorry, I forgot. If you have any question, I cannot see your question right now, but write the question, and I will stop a couple of times during the presentation, and we may want to read the question. But yeah, if you have any question, just write it right now, and we will read in a few minutes. OK, going back to our Galaxy. So this is the JSON. What I'm going to do this JSON is basically, OK, I have the JSON. I wanted to create a domain class for this JSON. And the guys who wrote HTTP4K did also this nice website or whatever it is, that you put some data, JSON, and it, voila, generate a Kotlin data class with all the fields of the JSON. So I can copy this stuff. Of course, it doesn't know the name. But apart from that, and he also put a lot of question mark, which probably is not really needed, but OK. And also, you can see that species, if you will look at the actual JSON, it was an empty. So you have no clue what it was, so you put any. But otherwise, it has a kind of reasonable guess to the type. So we go to our code. We have a class person. And we can copy paste this stuff. I did that before, so in case the site was down, but let's write. So basically, I just do this data class person. And OK, first thing I wanted to get rid of all this question mark. And then I want to, this should be a string. OK. And then I also probably want to say, okay, this you see that this film, species, vehicles are actually URLs. They are not just a string. So I wanted to use the Java URL plus java.net. Yes. So I want to do also this URL, and then this created and edited are actually time, so we can use an instant, for example. And also this is a URL. Yeah. Okay. So far so good. I have my class person. So what I want to do now, I wanted to create the JSON converter, basically. And I can do manually, but with the Kondor, I have a little generator, so I can just run in my test this Kondor generator. And of course, this is not working anymore because this is not a valid person anymore. So we can put something like to do. And okay, and if everything is okay, we should see. Nope, we are not seeing because we are not in the right file. But if we run now, hopefully, yes, we get the converter, basically. So if I go to this converter, yeah, you can see that I did this stuff before, but you can just replace. And yeah, sorry, there was a bit of confusion here. And you can see that it creates basically this converter. And the converter works as an object, so it's a singleton that is called, usually it's called like a J person for converting the person. And each field of this object basically is mapped on a field of the JSON. And okay, we can see that basically for each field, it can be a type of string or a type of object, or it can also be a numeric or whatever. Now, this is the conversion is not super intelligent, so we need to, for example, the instant are converted as a string, so we wanted to change it as a string, basically, not as a. And the URL, basically for the URL converter is called URL with the small stuff. So we can just do, and that's it basically. And also URL is a string, is not actually, yeah, it doesn't even need. So if it's a string, you should understand immediately. If it's an array, you needed to specify which converter use for the array. If it's an object, it's more complicated object, you need to specify the converter for that specific object. But now we have this JPerson created. And also, by the way, we also have the deserialization, which is kind of the opposite. And it's created automatically, but it's kind of convenient because sometimes you don't want just the constructor, but you need some special method or factory to create some object. So it's kind of useful. So in this way, basically, we can just put in our swap client, we can put our JPerson from JSON, and then we get the result. Or if the result is not good, we throw an exception. And just let's first have a go, just to make sure that it's actually working. And yes, you can see that here first it writes the JSON as it gets, and then this is basically the person. And we can also do something like basically if we put this as a variable, this is person, but we can also print the line the JPerson to JSON. There is a method to JSON that will return the JSON. And so we can kind of assert that apart from the order, the first JSON and the second JSON are exactly the same. And you can see that even if in the class the data instant, actually here they are string, and the same for URL. And so having this kind of library gives us some more freedom, because for example, now we can go to person and for example, and we can say, okay, this is the person data class, so I wanted to rename my stuff in a kind of Java style, and I can do this without any problem, because if I run the test, it will keep working, because of course I'm changing the code here, but I'm not changing sorry, basically this is the name of the field in JSON, and this is the name of the field on the person, so they can be very different. They can even be something that is not allowed in Java, for example, I don't know, something like that. It's not a Java valid, but sometimes the JSON are using this kind of conversion. So without using any annotation or stuff like that, I'm just explaining to Kondor that this is the way that I want my JSON. And a bit of more explanation. So for some kind of a type, I for example, for URL, I wanted to define what is called a string representable, which basically I'm saying this is a more complex type, but I wanted to represent as a string, so I just needed to specify two conversion variable, two conversion function, and then create this string helper function that basically does under the scene basically bind the parent object to my converter. And that's it. So basically, you can wonder what's the benefit at the end. I mean, I needed to commit this code, and if you have a multiple object, there are multiple file. It's also true that if for a domain, at the end, there are not so many, and you usually start reusing more or less the same object here and there. So it's not for in a real object. I mean, in the real world, in a real project, it's not that time consuming, and it's quite nice because you have the total control. You can check. It's much easier to see errors or stuff like that. There are no surprise comparing to using JSON or Kotlin serialization or other stuff that they work very well, but at some point there are some surprise, for example. What else I can do? I can talk a bit more about how it works behind the scene, but let me show from the website another couple of things. The advantage, you see, for example, with a bit complex invoice, you can use a more array of other objects inside and stuff like that. One advantage is that there is no exception. So also before we were talking about ATA, and Kondor uses its own internal ATA. I'm just using the internal one because I don't want to import arrows or force other people to import external library. But it works very simple, and in case you are using arrows, it's very easy to map the internal one to your general ATA. But so basically, you can either do auto, or you can use a more functional approach and using basically a map or a recover to handle both cases. I mean, good case, a bad case. And so you don't have to worry about exception. Whatever happen, you will have in the error. And also, Kondor already came with some special cases already embedded. For example, the enum work as you expect they work out of the box. If you have a seed class in JSON, they also work with a special JSON converter, where basically you just map a field name to each specific converter. So if this can be either a person or a company, you map, for example, the field private to person and the field company to company. And so you have this kind of JSON. But if you don't want to have this field called type, you can override and call it as you want. But it just, I mean, we are using this in production. It's quite convenient, very simple, and very transparent to know what's happening. Another kind of common things is that you have, for example, some class that basically decorate some other class. And your JSON will be basically, you have a file plus just a field. But you don't want your JSON to look like this. You want it to look like this, completely flattened. And you can do with, if you specify flatten here, basically it will flatten. Of course, that means that there shouldn't be a field called select in file info, for example. But this kind of thing, it's convenient, and also it's in the library. So if you needed to do something more crazy or more different, you just needed to create your special meta converter, and you can do whatever you want if you have some specification. Another kind of classical thing is that you have a map of a string. For example, for the properties or stuff like that. And you don't want to map to a kind of object. So it will basically be rendered in JSON as an object, but in Java as in Kotlin. So in Kotlin will be a map, so it will be just directly mapping. And you can also have a customer collection or strange format where you have the name of the field outside and the field are actually in array, because of some people like to do very complicated format in JSON. But the point is that you just need to define how your converter will work, and then it will handle all this kind of case. If you are using HTTP4K, for example, you can directly create a body length. So it will map directly the JSON converter to your HTTP in kind of a simple way. Okay, are there any questions? Can you read me the question, or can I? Okay, I can read here. Okay, that data deserialization. Yes, for example, for data, which is usually a pain. there are some something out of the box. So if you have for example, where did I put the but no, created? Yes. So this is instant, and this has been created as a string. So it will basically use a converter to instant to string. But if I wanted to create as a num, I can define as a num, but then basically it will be converted as an epoch. So the user the longer, a longer conversion in like milliseconds since 1970, and this will be managed as a long. And of course, if you have some, it just basically, if you look at here, this is the two. This is a number representable, so this is translating instant in a number, or this is a string representable, it's translating string to instant to a string. And the same is true for local data. I mean, this is a few things that are already inside, but you can always define your own specific representation. You just need to map from your type to some JSON basic. So number, string, Boolean. Number, string, Boolean, basically. Yeah. Or even object if you want, but yes, then. Okay, there was something, yes, sorry. Another thing that we actually had is that for our project, we had something that was required for the same type to be passed in two-way, one for the database and one for the HTTP. And this is quite easy to, because I can just do like this and say like, let's say the person database. And I can, for example, I can say that, yeah, here created is a num, and it is a num. I call user something different as something like that. And it works out the box. Yeah, now it's complaining because yeah, just this. Yeah, and so this just work that I just have a two different converter. So in my method, I can write a JPerson to JSON to have something, but I can also write a JPerson DB to JSON. And I will have something else. So if you have like API version A, version 2, or yeah, expect a number, but yeah, because it's trying to do the same. But I changed the stuff. But anyway, yeah, I think I left one. Yes, this is must be this time. But yeah, that's another advantage that yeah, you can see that in this case created is a number, and in this other case is a string. So it's a bit of work on front end, but I mean at the beginning, but then it's much easier for us to figure out all this kind of issue. And then we can refactor person as much as we want, and always without any, yeah, like this, and that's it. Other question. So Kotlin serialization library, what are the difference? I think I showed some of them. I mean, for us, the main one is that if you change your refactor your person, Kotlin serialization will change your JSON format. Another is that Kotlin serialization is quite a pain if for classes that are not in Kotlin. So for stuff that is from Java, stuff like that, you have to define. And it's much easier to define your custom converter in Kondor, at least we think, than using the Kotlin serialization. But I mean, if Kotlin serialization works for you, it's the JS prefix is ambiguous. Would you consider other prefixes? Well, the prefix is completely up to you. I mean, there is absolutely nothing in the framework that forces you to use one prefix. I mean, I think the generator creates something that is called JPerson, but I mean, you can even customize the generator. You can call this like JSON converter Kondor for person. It's a bit long, but it works absolutely all the same. So there's for us, I mean, in our project, DJ, it's good enough because we don't have we don't have any class Java class, so we don't have a particularly. Yes, actually, this is another great point. If we want to use Graal to create a native image from our code, which is something that we are looking at serverless, so we are kind of interested to that word. Yeah, this is completely without the need to load reflection. So it's probably faster. I didn't do very long, very detailed benchmark, but it's definitely not slow. And yeah, it doesn't need a reflection, so it's also very precise. When there is something that is wrong, it tells you exactly what is expecting at which point what went wrong. Yep. If there are other question, I'm happy. Otherwise, I can force you some functional stuff that you're probably not that interested, but maybe yes. I mean, I like functional programming. So, what Kondo is doing basically, if we look at a bit of theory, let's say, this converter is a JSON converter. And this basic JSON converter, well, it has a few methods, but the real important one are from JSON and to JSON. By the way, just a little one. There is also a way to use nodes, so you can have a representation using JSON node, and which are also completely functional, so they are totally immutable, which is much. It's very convenient when you need to do some operation nodes, because you just compose a node that are immutable instead of the JSON node of Jackson or JSON are mutable, which it's a bit of a mess when you try to do some clean stuff. But anyway, technically, JSON, I mean, Kondo converter is a profunctor. And you can wonder, okay, what is a profunctor? A profunctor is it's a category theory term. So, and you may know what is a functor is. So a functor is like a list, something that you can. So you can do something like list of 1, 2, 3 up, and then say 3, and then you get a list of 2, 4, 6, or you can say it to string, and you get a list of string. So this map operation is technically called well, list is a functor, so it supports the map operation. So the map operation plus the type constructor create a functor. Now, Kondor is not a simple functor. It's a profunctor, which is the union of two functors, basically. And so you have one functor, which is a normal functor, which is something that is called covariant, and another functor, which is a contravariant functor. And putting together, instead of having a map operation where you put a function, you have a demap operation where you put a two function, and you create a new profunctor. Does this as in point? Just a little. I can show you. The idea is that basically you can, using the map, you can map a converter to another converter. So for example, let's assume that we have a type, a product type, where we have a lot of product with the same exact description and price. And the only thing that is changed is the numeric. So we can define a demap where basically we say, okay, the only thing that we care is the new number, and the only thing that we care about the product is the ID, which is the same number. What's happened here is that basically you map your own J product to something that is only mapped to another type, in this case, a number. So you write 1, 2, 3, and you get the whole JSON for the product. You pass the whole JSON on the project, and you get back 1, 2, 3. And one possible use of this stuff is that if you need to have a very wordy JSON API where you only change a couple of fields, you can use your converter to a profunctor and just extract those two fields that change, and let's say that the rest stay all the same. And you have a converter that will do this for you. I mean, I don't know, it's kind of cool. Any other question? Otherwise, I can go on another bit. Anyway, if you want to, I totally agree that 7:30 in the evening is not the best way to study profunctors. But if you want to look at the profunctors, yeah, there is a lot of web content. So you can have if you kind of like this kind of things. I like this. It's kind of nice. What else? Well, the last thing that I wanted to say is that basically the parser is of a Kondor is done in completely in TDD, and is done in a kind of a totally functional way. So when basically you have a node string, then you have basically a map that map a node string to basically to a static function, which in Kotlin is not very easy to map a type to a static function, but okay. And basically here is how we pass a string. We use a function called surrounded that expects an opening quote, a string, and a closing quote. And everything here, and so for example, it's just an array is another surrounded, which has an opening bracket, an array, and a closing bracket. And if you look how array work, it is a comma separated, and then inside there is a new code. And if you look at object, is a comma separate with a parent node, okay, and then is a key value with a new node plus the key value. I mean, the key value will extract the key basically, and the column. So everything in the JSON is done in this. This is the whole JSON parsing file, and you can see that the longer function are 2 or 3 lines of code each. So it's also very easy to understand. Well, I'm not saying too easy to understand, but it's quite easy if you have some problem to see exactly what the problem is. There is no kind of code duplication, and there is absolutely no state. The parser is completely stateless, which also make it quite fast at the end of the day. And that's also, by the way, everything is done in TDD, so you can you have a test for any possible errors. And if you find some errors, I will quickly fix the code. I mean, if you write the test that show me an error, I will immediately fix the library. There was a few corner case or strange stuff that some other libraries, for example, doesn't handle these particular cases. But yeah, so you can find all the code here with all the text. Everything is open source and Apache license, and that's it. Let's see if there are other questions. No other questions, seems. I think I show you everything that I want to show. So I thank you, Enzo, and the community for letting me show my little library, and I hope someone else will find useful. And you can be confident that this stuff is used in production in some banks. So it's kind of rock solid. And if there are any bugs or stuff like that, we usually quite quick to fix. But that's there's sorry, everything is under, I should say, under GitHub, Uberto, Kondo JSON, and you can also open bugs, provide pull request. I mean, there's also some people that help. And for example, I don't use Java anymore, but this stuff should work in Java. And if someone wants to try this stuff in Java, probably this is not the right meetup anyway. But I'm happy to consider any pull request or improvement. Thank you very much.
Cool. That was really, really interesting. Like, I've always felt like annotating classes and stuff like that to generate code. It feels a bit like it's mixing the concerns, right? So it's really, really interesting.
To do a typo. I mean, I'm a bit dyslexic, so I prefer the compiler check stuff for me rather.
Yeah, exactly. And sorry for the lack of question. I think everybody, because the weather is quite good, everybody's at the bar. Cool. Well, thanks for that.
Thank you.
And
thank you.
Hopefully see you soon.
See you.
Cool. So that's all for this episode of Kotlin London. I think we'll be back on the 7th of July. And also thanks again to Raul and Uberto for the time, and to all of you for tuning in. We hope that you enjoyed the talks as much as we did. Sorry, being told we have a draw. Thank you. I've got the elves telling me that that we did promise that we're gonna give some prizes. So roll. Who's the first one? That'll be when does it stop? Oh. Yeah, I think we're gonna have to roll that one again. That might be considered rigged. Can we roll that again? Hey, Raffle. So get in contact with us through either Twitter or in the meetup, and then we'll get that license to you. And another one. So on the same one again. Okay, we'll do one for this time, and then we can save another one for next month. So make sure that you tune in for next time. Okay, no, they're also telling me that the other winner is Alex. So Alex, let us know in the either on Twitter or on the meetup page. So coming back to what I was saying before, thanks everybody for coming and tuning in. Hope everybody enjoyed the talk as much as we did. Remember, you can watch all our talks on YouTube, so make sure to keep an eye on there and check them out. And from Guillermo, Enzo, Amar, and me, stay safe and see you next month.